Our solar system is a busy place, with planets orbiting the sun. These planets move in paths that are not perfect circles. They are slightly elongated. Scientists have a new idea about why these paths are this way. They think a giant object passed by our solar system long ago. This object was much bigger than Jupiter, the largest planet we know. Imagine this object visiting billions of years ago. Back then, our solar system was young. The planets were still forming. This massive object would have been like a cosmic bull in a china shop. Its gravity, a force that pulls things together, would have tugged at the young planets. This tugging could have stretched their circular paths into the elongated ones we see today. This new idea is exciting because it changes how we think about our solar system's history. It tells us that things from far away could have shaped our cosmic neighborhood. For a long time, scientists thought our solar system formed in a specific way. A cloud of gas and dust called a protoplanetary disk swirled around the young sun. Over time, this material clumped together to form the planets. This model suggested planets should have circular orbits, all in the same flat plane. However, the giant planets like Jupiter and Saturn don't quite follow these rules. Their orbits are slightly tilted and stretched. This mismatch between the model and reality puzzled scientists. They started looking for explanations. Some thought the planets themselves might be responsible, their gravities pushing and pulling each other into odd positions. Others thought a distant disk of icy objects might be the culprit. But this new idea throws another contender into the ring, the massive interstellar object. This theory challenges our assumptions about how orderly and predictable the early solar system was. It suggests that random encounters with objects from interstellar space could have played a significant role. Scientists love to test their ideas, and what better way to do that than with computer simulations? They created a virtual version of our early solar system and threw in a massive object to see what would happen. They experimented with different sizes, speeds, and trajectories for this object. Imagine this. Scientists huddled around computer screens watching as virtual planets danced under the influence of the intruder. They found that an object 2 to 50 times the mass of Jupiter, passing relatively close at a slow speed, could create the tilted and stretched orbits we see today. These simulations didn't perfectly recreate our solar system, but they showed that a close encounter with a massive object is a plausible explanation. This idea, once just a theory, now had some evidence to back it up. Section 4. Rethinking planetary systems. This new research doesn't just change our view of our solar system, it changes our understanding of planetary systems throughout the universe. If a massive object could have wandered through our cosmic neighborhood, it could have happened elsewhere too. Suddenly, the diversity of planetary systems discovered by astronomers makes more sense. Some systems have planets in wildly different orbits than ours. Some might have even lost planets due to these cosmic encounters. This realization is like finding out your quiet town is actually on a busy interstellar highway. The universe is full of surprises. This research reminds us that the formation of planetary systems is a complex and chaotic process, influenced by factors we are only beginning to understand. Section 5. A universe of possibilities. The idea of a massive interstellar object shaping our solar system is a powerful one. It challenges our assumptions and forces us to broaden our horizons. It reminds us that the universe is a dynamic and interconnected place where even chance encounters can have lasting consequences. This research is just the beginning. Astronomers will continue to search for evidence of similar events in other planetary systems. They will develop more sophisticated simulations to understand the intricacies of these cosmic interactions. The more we learn, the more we realize how much more there is to discover. Our solar system, once thought to be a well-understood system, now holds new mysteries and a reminder that we are part of a vast and ever-evolving cosmos.